be able to give an update today.
Okay. Tom, do you want to give an update on the CNI side?
Sure, yeah, I can give a very quick update if you can hear me okay. So we had a CNI maintainers meeting yesterday that Minhan came to, and also a couple of folks from Mesosphere as well. And I think we've come up with something for the CNI spec changes that everyone's almost happy with. There's a PR up in the CNI repo at the moment, the latest PR 369, if anyone wants to take a look and comment. But the intention, the hope is that there's broad consensus on that. We just need to work out some of the details, and that should get merged soon. So hopefully that from the CNI stuff is resolved, almost resolved, and yeah, I'm not sure about like the Kubernetes side of actually implementing that.
Cool, thanks. Yeah, so that should get Minhan hopefully everything that he needs, and I will. It sounds like he's already aware of that if he was on the meeting yesterday.
Yeah, and he's commented on that PR and stuff. So
cool.
Can I ask a clarifying question here? Are we talking about changes that have already gone into the spec, or are we talking about changes yet to go into the spec?
So it's a pull request that's open at the moment that's actually clarifying some things in the conventions documentation. So it's not directly a spec change. It shouldn't require kind of code changes for libcni. But yeah, it's a PR that's up that's not been merged yet. So if you want to comment on it, then go and take a look.
Cool, and it looks like there's a link to that in the chat now for anybody who's interested. So next on the list was a quick update on network policy. I don't see Dan Winship here, but I believe the state of that is relatively unchanged from last time. There's an open PR which attempts to move it to V1 and is awaiting feedback. So people who are interested in that, please take a look. I know Dan had some outstanding questions on that PR. There's a link to it in the comments. Where'd my agenda go? So if Dan Winship's not here, then we can move on to some of the other stuff. So there's a question about what is a tenant, and if there's a general consensus that a namespace is a tenant boundary. I'm not sure who added this topic. My understanding is that there's not consensus that a namespace is a tenant boundary, and that, you know, from previous discussions, tenants are less well defined than that and could potentially be multiple namespaces for a single tenant. Who
So that is me. Can you guys hear me?
Yep.
Okay, yeah, right. So I keep hearing people talking about tenants being namespaces, and I see people going ahead and coming up with networking solutions based on that. So in the larger Kubernetes community, are people converging towards this namespace being a tenant boundary, or are we at least a year or two away from that definition?
I would say the challenge is the tenant is not a simple concept. So I'll remind you of what I'm hearing from people who want to use Kubernetes in a non-trivial way. I'm dealing with a couple of organizations in the software as a service business. So they have what I refer to as two-dimensional multi-tenancy. They have multiple service offerings, and cross-cutting that, they have multiple customers. So we don't have a simple, there's different degrees of focus or kinds of scope that is relevant to talk about here. So for example, in such an organization, each pod is dedicated to one customer's use of one service, and they plan to have a namespace per service and customer that is a meaningful pair. They also have some namespaces that are central per service that are not dedicated to a given customer, but do stuff like monitoring and management for that service. They also want to have some namespaces that are central per customer that are not dedicated to any one service's interaction with that customer, but are more shared issues for that customer. So you can think of this as a two-dimensional matrix describing what's going on within that organization, where some cells are filled and have a corresponding namespace, and some cells are just blank. And the necessary access that they want between namespaces is across rows or across columns. And then they also want to have operators for the whole organization that have access to the whole matrix. So that's, I think of namespaces as kind of the finest grained kind of tenant, but tenancy is not simply namespaces. And nor is it simply a hierarchy of namespaces, right? Some people will say an organization is a bunch of namespaces that can all see into each other, or that all have the same, uniform relationship to each other. And that's not what we need here.
All right, so I guess the answer is that the community in itself hasn't really deep dived, and they haven't decided to solve this right away or something like that, wherein they define what is a tenant.
I would disagree. I would say we've had a lot of conversation, and I would say there is an emerging consensus around the view that the namespace is the atom of tenancy, but we need to be able to construct more complicated relationships, and we're not going with, again, a simple hierarchy. We want to allow more fine-grained and structured relationships. So I think the agreement on the atoms is I think there's pretty much a consensus on the atoms. It's how we build the molecules and bigger structures that we're still trying to figure out.
All right.
This topic may be relevant with the SIG auth also, because as we build those molecules, the authorization aspects play a more important role rather than just the network.
Yeah, and we've had some joint calls with and communication with SIG auth in the past, and I think they kind of agree with this model of a namespace being an atom of tenancy. And from my perspective on these discussions, it's been clear, that there are a number of different ways that people want to use Kubernetes as a multi-tenant solution, and it's not necessarily Kubernetes community's job to declare one right solution, rather to provide the tools to make all of these possible. So unless there's any more discussion, does that answer your question?
Yeah, I guess. Yep.
Great. So next item on the list was DNS. We'd spoken a little bit last week or 2 weeks ago about shared DNS or DNS per namespace. Is there somebody on the call who would like to talk about that?
Yeah, I put that one there. So I think when we last talked, there was a general feeling that we would prefer a set of shared DNS servers. My problem is I just don't know how to make that actually work, because as far as I know, Kubernetes will sometimes masquerade the client address, so a shared DNS server can't identify the client.
Yeah, I guess this is Bowie here. The question probably would be, I think you mentioned it in the context of trying to kick off some tenancy, sort of some notion of tenancy in the namespaces. And I think, at least I was looking at the document, I kind of wanted to understand, if we went with a per namespace DNS server today, like how would that look once we have the more complicated tenancy issues resolved in the future?
Yeah, I think the issues separate. So there's a question of how do you identify the client? And one is you can look at its IP address, and the other is the server can be specific to the client. And then the other questions are, how does this DNS server, enforce the appropriate or desired access? And again, if you have the server specific to the client, there is, a tantalizingly close opportunity to let what's visible in DNS be a natural consequence of what's visible through the API. And I tried to have a conversation along those lines in the SIG auth mailing list, where I was pointing out that that's really just not the way the API works nowadays, and we would need to push some non-trivial changes up through the Kubernetes API server into etcd in order to make that work. And that might be a viable path, and there might be something else that could be done in the meantime, and OpenShift seems to have done something else in the meantime that's kind of like giving these kind of synthetic views. See, so the observation is that the way the DNS server today in Kubernetes works is it does a list and watch on the API server for services and tracks the endpoints of each service. And if only it were the case that the API server were to respond to that list and watch request with a view that shows only the services that this client, that's to say the service account of the namespace in which the DNS server is running, is authorized to see, then the existing code would just work. But it's not going to anytime real soon. I mean, who knows, maybe. So there's another way to approach it, which is, again, have something else that synthesizes the desired view as in OpenShift, or make, again, something a little bit more specific that just for maybe DNS solves the problem more directly. But the point is that whatever, I think what I'm trying to say, however, is whatever we decide is the kind of way of expressing this molecule concept, that can be implemented either in the DNS server or a proxy as an OpenShift or in the Kubernetes API server, making the right stuff visible.
I see. In terms of, I guess, specifically what needs to be answered at this point, shared versus pure namespace, because it seems to me like it seems a little bit of an implementation detail, because let's say you have some mechanism to poke in the shared DNS server, but with a different endpoint, for example, but it's the same one and somehow is able to identify the client. Is that the sort of what you want to resolve with the question?
Well, I mean, there's several questions to answer. I'll need them all resolved. So if you can find a way to make a shared server work, let's hear about it. I mean, obviously, we would all prefer to have fewer servers. So, I mean, that's one of the questions. Another issue with if you have a shared server, however, again, is this issue of how do you get the right restrictions applied, right? If the server is specific to the client, then it can potentially inherit the restrictions that are already applied to the client. If the server is not specific to the client, then the server has to go and impose restrictions, like say the proxy does that's in OpenShift or something. But somehow it has to impose the restrictions on its own rather than let those be a consequence.
I see. So I see.
In some small testing that we've done, we kind of created almost similar to the cluster first type of policy, and then in the kubelet, have it look for that specific type of namespace first type of thing, based on an annotation in the pod. It's kind of hacky, but it was like an interim approach at the moment. It's attached to the proposal for this too.
Right. Yeah, I guess my only concern at this point is how does this go forward in the future, which it seems like it's okay. And then the other thing is scalability with respect to number of namespaces. So is this required for every namespace? Could they possibly be shared in the future? If you have a cluster with thousands and thousands of namespaces, how would this work?
Again, I think that's kind of a use-based specific question, unfortunately. In the use cases that I'm most concerned with, the amount of work done in a namespace is much bigger than the amount of work that will be done by the DNS servers. So there's a lot going on in each namespace. So throwing in a few DNS servers into a namespace is not a real problem. But in other cases that I'm aware of that I'm not focusing on at the moment, it's exactly the opposite. Right? We have a public service where people come by and kick the tires. Maybe you give each tenant their own namespace, and they do almost nothing with it. And so if you have to add the overhead of 3 DNS servers on top of almost nothing, you've blown up the cost of a looky-loo by a huge factor.
But it sounds like the name server should go with the tenant, right, rather than the namespace itself, based on what you just said.
Well, no, I would disagree. Because again, the idea of if you take namespace as the atom of tenancy, and then you have control over what kind of access can happen from namespace to namespace. Yeah. Again, we're mixing up two issues here, right? One is just how do you implement that, and the other is how do you identify the tenant. So again, if the atoms are namespaces, it seems to me, again, if you share a DNS server amongst multiple namespaces, you got to figure out which namespace your client's in. And I just don't know how to do that, given that Kubernetes will masquerade in some cases.
You mean the kubeproxy will masquerade?
Well, Kubernetes doesn't even mandate that you use kubeproxy.
Right.
Kubeproxy doesn't mandate whether you use it in IP tables or user space mode. Even in IP tables mode, it will masquerade in some cases. In user space mode, it masquerades in all cases. So there's lots of cases in Kubernetes in general where you just can't rely on the client IP address being the pod IP address.
Yeah. I think it really boils down to your original point, whether namespace is really an atom of multi-tenancy, or is it a building block that can be used to build a molecule of multi-tenancy?
No, there's not a distinction. No, when we say it's an atom, we're explicitly contemplating building bigger things with these atoms. That's why we use the word atom. We all know what you do with atoms is you build bigger things.
You do build bigger things, but do you need like every attribute inherent into that smallest unit? Is really the question. Or can you build it at a slightly higher level? Which is what you were also saying, I think. I mean, the question really is: do you need a DNS server for every namespace, or you need a DNS server at a slightly higher level, maybe multiple namespaces built into a tenant?
Again, if you want to make a distinction among clients, I don't know how for DNS servers to make a distinction among clients. So the only sharing that I know that you can reliably do in Kubernetes is amongst clients that should all get the same view through DNS.
The hard thing about using the namespace as the tenant too is you can imagine that 2 tenants have services that they want to build off of each other. And then in the namespace first kind of policy, if you only can ever see things in your namespace, you could never reach anything it would have to be deployed within that namespace. So it kind of breaks namespaces in some regard.
Well, I'm not sure what you mean by namespace first. I think that came up in the context where we proposed that there be a annotation you can put on a namespace that says cluster first means use this DNS server. And someone says, well, no, that's just namespace first. But that's saying use this DNS server. That's not saying anything about what view that server presents. So when people say namespace first, I think they're just talking about a way of accomplishing namespace-specific DNS client configuration. And we'll need this if there's not a universally shared set of DNS servers. You'll need a way for the kubelet to put the right client config in each pod. But that's a relatively separate and easy problem. I think the harder problem is we would all prefer to have shared DNS servers, but as far as I can tell, in Kubernetes, you can't share DNS servers among clients that should get different views.
Yeah, I would love to discuss this in more detail. I don't know if we're going to resolve it in this particular meeting.
Yep, I agree. There is a design doc open for this, if I remember correctly. Mike, is that the place you would want people to follow on with this discussion?
No. Well, again, I think that kind of wraps up multiple issues. And there was a issue open that wrapped up multiple issues, and I'm trying to tease things apart. So I see two issues here really that are pretty separate. One is, can we share DNS servers, and if so, how? I haven't seen any way, and I opened a thread on the SIG Network mailing list for that. And the other issue is, okay, how do we want to actually, in the DNS server, how do we want it to actually get different views? And I opened a thread on that in the SIG auth mailing list because it seemed more like SIG auth material.
Great. Just jotting that into the notes. Cool. So it sounds like we should continue that discussion on those two mailing list threads. So the next thing on the agenda was multiple networks. Joji, are you here?
Yeah, I'm here. Yeah, so we had a lot of discussion. We have a design doc open. We have had quite a bit of discussion and a lot of interest as can be seen in the doc. So at this point, I think we need to figure out what the next steps are. I have started prototyping some of this, except for the last week I was too busy with my own work, so I was not able to get to it, but I started prototyping it. I think we still need some of the things, probably a little more conclusion. I think one point of contention has been whether there needs to be routes injected into the pod. If so, how? That's one item that has come up quite a bit in the discussion. So the way I see this, if you have two network interfaces in a pod, that inherently means that you need some routing information inside the pod. And I think I also summarized this in the document as well, because the pod needs to be able to tell which of the two networks it uses for a particular destination. That's one thing. And the second thing that has come up quite a bit is whether the configuration should be like a cube level configuration or should it be a node level configuration. So I've tried to address that by keeping it flexible enough so it's not directly through the cube, taking it out so that it can be configured out of band. So any further suggestions?
What can be configured out of that?
Basically all the IPAM related information. So like if you want to create like a local network on the host, you can do that. If you configure it, I guess on the cluster, it probably has to be like the same on every node. I think that's why some people have concerns because they would probably like to use different networks on different nodes.
I think more precisely the issue was, does the details need to go in a CNI config file on each node, or can the details go? I think we saw three approaches in that document. One is the details go in the Kubernetes API object. One is the details go in CNI config files repeated on every node. And one is the details go in an external SDN.
Right. So the first approach is what I was trying to do, Mike. The Kube API is the approach that I was trying to take. The idea was kubelet can fetch it from the API server and feed it into the CNI config. But now the problem is that potentially be seen as not flexible enough. If this were to be in an SDN, you probably have a little more flexibility.
Right. Yeah, I'm sympathetic with Dan's argument presented in that document that yeah, it does not belong in the Kubernetes API. I'm also sympathetic with the argument we don't want to have these things be reified as files repeated on every node, particularly if they're created
Exactly.
dynamically, right? And I'm sympathetic towards the approach that says it goes in an external SDN, because that's pretty much what we're all doing anyway.
Right. So, so the approach I thought that seemed to make sense flexible enough was to keep it outside the API and not specify how it is configured. So that way, that leaves the option of either putting it in the CNI config manually or having it in an SDN configuration. Does that make sense?
Yes, but as I just noted shortly before this meeting, also there's a question of access control. And access control to the API objects in Kubernetes is one thing, but if they're just references to an external SDN, you may also want to ask about access control to the SDN.
Well, so the idea is in this case, the kubelet is not involved in accessing that, right? So that object is not required. So kubelet is not going to try to access that object at all.
Let me put it another way, as just part of this problem. If an API object for a network contains a reference to a pre-existing, already defined externally SDN network, and this is actually, can two network objects refer to the same external network? Right? Particularly if they're namespaced and you want to have multiple namespaces accessing the same external SDN network, you need to allow multiple networks to refer to the same external network. So it's kind of natural to say, okay, they're not one-to-one, they're different things. So what stops someone from making their own Kubernetes network object that refers to any given external network?
What stops them from?
Nothing. Nothing stops them. So why do we even want to refer to the external one?
I mean, just to keep it flexible, like I said, so there are like three different, viewpoints that we need to consider. So the idea of keeping it external was to just refer it using a name, so that the details of the actual configuration can go into the SDN or the CNI config itself. So now I guess the question is, if you refer to the same object using a different network object, so that's definitely what we will be losing by doing this. But having said that, as long as there's an SDN, there are always things that you can do that is not strictly following the kube RBAC model, right?
Wait a minute. This is not how I was thinking. I thought that we could create API objects which are created by the administrator, and the users or the tenants or the namespaces or whoever behind the RBAC or free or whatever are allowed to use those depending on their authorization. So I, as a normal user, would never be able to create a network object by itself. I cannot create my own network. I can only use the networks that my administrator has apparently allowed me to choose from 1 or 10 or 20 of them that they have created.
That is true.
And then there is no question of two network objects trying to refer to something which is outside their, right or something. So because they've been created by the administrator, it's locked down. If you want to create another network, then get the administrator of the cluster to say, hey, well, here is another network. Now, anyone and everyone can use this, or maybe some of them can say, hey, I am a pod. I want to use this network. Can you add that as an interface? Add that as an interface to my whatever deployment I do.
Yeah, that is definitely true. But I think the definition of an administrator can be a little bit of a gray area. So if you define it the way that you just did, then I think we're good.
Yeah, I think that approach
works. Sorry.
I think that approach works, right? I mean, there's a distinction really between those who can make the connection to an external network and those who can just use one. And we can use RBAC to, control those two independently.
Okay, so then
I have pasted in the document at the end of the multiple network document, use cases that I have gathered from users. It's no way a complete list, or maybe even some items are redundant here. may I request people then to just go over it. Some of these are kind of little out of the regular things that we get to see in the Kubernetes cluster, especially point number 5, if anyone is looking at it. I got use case where there are some requirements with some pods which require like up to 64 interfaces in a container. And they have a real use case, and it's not for web traffic, that sounds very silly, but for NFV cases, it's not out of the world scenario. For those, I don't know how we're going to solve them. So we need to get to a really scalable model of having multiple networks. The case, I think, with whatever Joji had described, I think I mostly agree. I'm still not sure on how do we solve services. There is a use case where one may want to create a service that's, let's say a pod has 3 interfaces inside it. And I want to create a service which addresses only the second interface. How do I create those endpoints to the service? That would require changes to the service, or do I say, hey, well, that's left to the creator of those endpoints, which means a regular controller which creates the endpoints for a service is kind of disabled. We will have to write our own controller which looks at those service objects, checks out if there's an annotation or something which refers to the second interface, which means I would populate my endpoint object, where I will pick up only the second interface. This is endpoint. Even before that, if I have multiple interfaces in a pod, how do I know which is, how do I, in the status object, for example, how do I get the actual IP addresses? Do we even need those? Have you thought about those cases?
Yes, so that we have already talked about, Rajat. So if you look at the document, there was a discussion. And so basically what we said was for backward compatibility purposes, we will define the first interface as the primary interface, and that will show as the pod IP in the status object. In addition, we will add a list object that will list all the interfaces and their IP addresses. So you have backwards compatibility, where your primary IP will be seen always, and you have this new object or new field that will show you the list of IP addresses and interfaces.
So, okay. Are we locked in on this new field on the service spec? Everyone agrees with it?
I think so. Based on the discussion in the document, I thought that was a non-controversial item. So coming back to the issue of redirecting service traffic, so as I pointed out earlier, I think this is essentially a routing issue again. The problem we have is right now we have the restriction that all services get a cluster IP from a single subnet. So like I said, if this is a scalability issue, see like where you have like services going randomly to each different network, then we have a problem. But if it is more like an exception than a rule where one particular service needs to go out on a different interface, we can certainly like predefine a service IP or cluster IP and then use routing to redirect it. But a more clean solution would actually require that we make the service cluster IPs more flexible, where there is a way to specify the cluster IP as part of the service definition. I think it's an optimization, the way it is defined right now, where all service IPs, cluster IPs have to come from a single subnet. If you really think about it, there is no need for it to be from a subnet. But to me, it's more like a data path optimization, where you can use, consolidated rules to implement your IP tables, masquerading or whatever.
Right. So I would suggest not necessarily that each service has to pick the IP, but maybe it picks the subnet or the network that its service IP is drawn from.
Yeah, that would work as well. Yeah.
Hey, I have a question for Joji. So you mentioned that there was a discussion where the configuration of the network should live, like it shouldn't stay on the API server and it's part of SDN controller. So, and it cannot stay on the individual hosts. So what do you mean by when an external SDN controller? So it is like another Kubernetes service and it has its own database backend?
No, so the idea is, so we talked about, this was actually the very first discussion we had on the topic, right? So there are three ways to do this. One is we put the required configuration in the Kubernetes API object. But so in that case, the issue is there will be people who will want to have some configuration that's specific to each host, right? Once you define it as an API object, it has no concept of a host or a node, right? Regardless, all the nodes are equivalent from that point of view. So you will get the exact same configuration on every single node. So so there are certain use cases where that is not acceptable. I mean, they need to get a node-specific configuration. So the suggestion was that we create a file on each of the nodes with required configuration. Obviously, that has its disadvantages that you have to replicate on every node, and you have to have this concept of having node-specific configuration. So which is why we wanted to take a flexible approach where you can have node-specific configuration if you have to, or you can have a cluster-wide configuration if you have to. So which is why we said we can move this object into the network implementation. So when we say SDN, we really mean the network implementation. So whoever is the network plugin, that plugin can maintain this configuration. The Kube API will just refer to the network object. I mean, the network plugin object just by a name. You can pass that name reference into the network plugin, and it can go from there. When it comes to things like all the IPAM things, right? So what is a subnet? Things like that.
I see. So, but this is still, so if you say a network object, right? So a networking plugin still doesn't have information about the host capabilities, right? So, so the summary is like we have three different ways of specifying multiple networks in the configuration. Is that the final? Is it the summary?
No. So we will let, so in the network object, we'll just have a reference to the network as defined by the network plugin. So things like what is the IPAM configuration, what's the net mask, those things will be defined inside of the network plugin object. When you approach it from the API service perspective, it will just say, I need an interface on this network, and that network will have a name. It will not define what is going to be its net mask, for example.
I see. So the scenario that I'm looking at is like, let's say the different hosts in a cluster are not identical, and there are like, let's say host one has only one ETH0 host network, and let's say host 2 has 2 different or 3 different networks it belongs to. So now a network plugin doesn't know about all these interfaces. So at this point, there is an information which is specific to the host. And so how do we capture this kind of a situation?
So I don't know. I mean, I would let some of the more Kubernetes people to comment on this, but I think in general the assumption is that we shouldn't be bringing in details of the node into this API object. If there are such host-specific things, that should be hidden by the network plugin from the cluster-wide, because as far as the API objects are concerned, all the nodes are considered equivalent. But now, if you cannot schedule a particular pod because of such restrictions of the node, that should be made known to the scheduler or the Kubernetes itself by applying sufficient restrictions. For example, this is no different than, you're saying that a node does not have sufficient memory to run a particular pod. How do you make that visible to the scheduler so that it does not schedule the pod there? So to me, it is that kind of a problem.
Okay.
Great. So Joji, next steps for this. Do you still want more discussion on that design document? Is that?
If we can we say, is it reasonable that we take this, the conclusions that I mentioned? If anybody has objections, then we can discuss more. Otherwise, I think we should just move forward at this point, and we can have more discussions later on if necessary.
Well, I'm not quite sure I understand. So there is some ongoing discussions. Are you saying we just take them all as resolved by the text as it is?
Unless you want to, do you like to see changes there? Then
well, look,
okay.
we have in this review in the Google Docs, you have a way of marking comments resolved, right? One way to proceed
I can.
would be to mark all the ones that you believe are resolved as resolved, provided that the current text is actually, adjusted to reflect the resolution. And
let me do that.
Give it, right, and then give it some time for people to give it a final review and see if they agree that the issues have been resolved.
Okay, that makes sense, Mike. Let's do that. I'll do that.
Cool. So we have 2 more topics on the agenda today. Christopher, you gathered up some test coverage results?
Yep, I posted them in that linked document there. One thing that I didn't exactly note is what are all of the components that we would say belong to SIG Network. So I chose the ones that I thought were most obvious to me. So could be that I missed some or added some that were not directly part of ours. But in a lot of the other SIGs, well, in SIG scheduling, they were creating like a master issue for these and then kind of partitioning them out in order to get each package over 80%. There's a few in there that are not, but I think mostly we've been doing pretty well on those. So if everyone can comment on the doc with any packages that I missed, and also any that I put there that do not belong.
Yeah, I believe that there is a quote-unquote master list floating around somewhere about which packages or which tests are related or the responsibility of each SIG. I'm not sure if that is just E2Es or if it includes unit tests as well. But if you're not aware of that, then I can try to find that for you and compare that against the packages you've covered in that doc.
Yeah, I was not aware of that. I can try to look for it.
I have a stupid question here. Is there a way I can adjust my view of that doc so the lines don't get broken, so that it's wide enough so that the lines just don't need to be broken?
Yeah, I kind of copied the format from Emacs, so I'm not surprised that it showed up like that.
Yeah, I mean, it would be real nice if it were like, if there was like a way I could just glance down a column and see those coverage numbers. That'd be a nice way to present it.
Put it in a spreadsheet.
Yeah, would it be better in a sheet? I could do that.
Yeah, if you could, that would be a little more consumable. Thank you.
Yeah,
is this
I think
that we would like to do for 1.6, or I don't know if it was in kind of our list of things to accomplish for 1.6.
Yeah, I mean, I think that testing is one of the areas we identified as something that we wanted to look into, right? We didn't have a good sense of what our coverage was. So I think what you've done is a good first step in identifying where we should be adding tests. And I would say if somebody has, or multiple people have time to try and chip away at some of those numbers in 1.6, then that's something we would want to do.
All right, sounds good. So I will change this to a spreadsheet and look for that master list to see if anything that I missed.
Yeah, I can try to find that for you. Great. So the last thing on the list is named ports in network policy.
I edit that. Hi, it's Brian Gorham here. Yeah, I should have brought it up under the update on network policy. So per the link I put in there, something that I certainly wasn't aware of, the port entry in a network policy can be a name, like HTTP. And it turns out that those names in Kubernetes do not always have to map to the same number. It's a documented feature of Kubernetes that you can have named ports and remap them to different numbers as you upgrade your software. So the real question is, do we think network policy supports named ports, in which case I believe all the main implementations have an interesting piece of work to do? Or do we want to say, actually, network policy only supports numeric ports?
Yeah, it's a good question. Certainly, as the spec is written today, it does support named ports. And like you said, I don't think any of the implementations actually implement it. I myself have not heard any users using that feature or trying to use that feature. But it is, like you say, a supported feature of Kubernetes. I don't think that it's necessarily a super hard problem to solve in the implementations, but it's not trivially straightforward.
Yeah, I'd agree with that. Well, I guess, like, we're trying to talk about moving out of beta into V1 for network policy, and are we happy doing that with a part of the spec that we know for sure is not implemented by anyone?
Yeah, that is definitely a question. I think it would be a bit unfortunate to do that. So we could have a pragmatic solution of we don't support that V1, or we push out V1 until the implementation supports it. I'm kind of interested in getting Tim's opinion on this. I believe he was originally.
I'm getting a really weird distortion. I think someone said in chat the same thing.
Oh, I thought it was a meta. I just want to point out something also. So in the ingress spec, also the backend allows the service port to be a name and an integer. So we also have to look at that.
Sorry, I missed that point.
So you were saying that about the ports in the network policy were being used as a names, could be names or an integer, right?
Yep.
Also on the ingress spec, we have the same problems because the backend on the backend service port can be specified as an integer and also as a name.
And is there something where we specifically have to make a decision because we're trying to move it out of beta?
Yeah, we should look at it. Since you brought up the network policy problem, I think we should be more precise on both specs, so it can be we can have.
Hang on, what is the status of ingress? Is that a beta or V1 or I don't know off the top of my head.
I think it's V1 beta.
Yeah, I think it's beta.
Okay, and is there a proposal to move it to V1?
There is, I'm not sure.
I'm not aware of a formal proposal now.
Okay, so I think it's way more urgent to decide because we're actually thinking of moving network policy to V1. I mean, I take your point that that's an interesting consideration about ingress, but.
So have anybody on this call interacted with users who are looking for this feature?
Yeah, it never came up. I didn't know about it until I read the thing today.
Yeah, I mean, that kind of matches my experience with it as well. It's not a feature that users have asked for, but I remember Tim was adamant about it being included in the original spec, so I think we probably need to speak with him to see if he had particular users that he was aware of that were using it, or if it was just well, services support this, so network policy should too.
Well, it kind of seems to me like it's coming down that is what was meant, and it's a quality of implementation thing.
Yeah, who should be making the translation? Should be Kubernetes or should be the implementation?
Well, the difficult thing is that the translation can be different for every pod. So it doesn't really matter who does the translation. It's quite an extra piece of work.
Oh, okay. I thought you were meaning the names of the protocol ports and the protocol names. Okay, never
well,
mind.
Yes, but Kubernetes has a particularly flexible way of viewing those names.
Yeah, so you can specify a port in your network policy ingress rule, which is web, and that maps to port 80 on one pod and 81 on another pod and 82 on another pod. They're all selected by the same ingress rule, or have the same ingress rule applied to them. So it's definitely a question we need to answer moving to V1, and I think that Dan Winship had raised it on that PR.
Yeah.
So perhaps we should finish that discussion there. I mean, I think my take is that we either need to remove it from the V1 spec, or get one of the implementations to support it.
Okay.
All right. So that's the end of the agenda. Any last questions? You've got 3 minutes left. If there's anything else you wanted to discuss. Nope. All right. Well, we'll meet again in 2 weeks. Thanks, everybody. Cheers.